Good morning, everybody. My name is Anthony Bartolo, and today we're going to be covering IoT, computer vision, and ops. Awesome to be here at Microsoft Build. As you know, it's one of our bigger conferences that were made available, and the fact that we've done it digital and we're coming into living rooms and offices of your homes is an awesome thing. Please feel free to ask your questions in the side chat window there, and I will do my best to answer all the questions that have come across. So without further ado, let's begin. All right, so as I mentioned, we're going to be talking about IoT, computer vision, and ops. And it's interesting because there's been a lot of conversation, especially at this year's build, in terms of ops inclusion in respect to how data is transported, how data is secured, who's allowed access, the whole just-in-time access capabilities of the data made available. And if you've seen my talks before, I like to showcase examples of real-world implementations of this technology and how operations came in to help support the initiative. The biggest thing here is the conversation that has to take place. You have to have an open dialogue with the business decision makers at your organization, the developers at your organization, of course, your IT department. All three have to come into collaboration in respect to implementing a solution or a technology. IoT, computer vision is no different, right? The whole aspect of these devices that are out there and capturing information and relaying information from an endpoint, hugely beneficial and important to have them secured, to have only certain individuals have access to it or certain services have access to it. The ability to control where the data flows. And to, I believe the gentleman's name is Menteas's point, how the data is encrypted at point of entry and at point of storage. So AI. This is, something where a lot of organizations look at this as the crystal ball and say, if I apply AI amidst my organization, I'm going to either A, save a lot of money and save a lot of overhead, or B, make a lot of money because I'll be more proactive. I'll predict what my customers want. I'll know in advance what my organization or my company needs to do to be successful. The biggest challenge here is that without that dialogue between the business decision maker, the developers, and the IT professionals, is you'll have these silos occur and individuals working on their own, not collaborating with the business as a whole. Of course, everybody's trying to put their best foot forward in terms of supporting an organization, but in this scenario, if groups are not working together in terms of that implementation, you'll have what's called fragmentation. And in that sense, or scenario, I've seen a lot of horror stories happen where technology is applied and devices are connected for the greater good of the organization, but security is not put into place, or ISO standards are not taken into consideration, or even worse still, I'm going to add the latest and greatest technology to my organization, but it doesn't pertain to my business's needs. These are the things and scenarios that we have to take in consideration. And that's, again, why I emphasize that this relationship is so important, because the fact that without the collaboration of the team as a whole or the organization as a whole, you will not be successful in terms of the implementation of that technology. Having a stakeholder from each, the business decision maker, the developer, and the IT operations departments is a crucial piece to ensure the success of your deployment of these technologies. So now I'm going to dive into a couple of the projects that we've done, and this is the opportunity that I myself, as an IT pro in the operations department, came in regards to the deployment, the security, and implementation of this technology. So the first project I actually jumped on was this one, which was called MouseTrap. This was taking a literal $2 mousetrap and connecting it to a Raspberry Pi. The opportunity here was having these mousetraps laid out inside of a warehouse. We deployed 100 of them. And when the mousetrap went off, it would actually capture information in regards to, where the trap was inside of the building, where the trap was geographically, what was the temperature around the trap, was it light, was it bright in the area, was it dark in the area, all this information being captured. And the importance here, it provided information through IoT Hub into machine learning to understand, hey, where are these traps inside of the building? How successful are these traps in regards to catching mice? And where are better placement of these traps inside of the building itself? Now, operations in this opportunity, this project was crucial because of the fact that a couple things. One, there were many reiterations of the software for the mousetraps themselves. And it was up to IT, this is myself in this project, to ensure that the versioning of the mousetraps was such that we're at the best foot forward on the versioning itself, and ensuring that there was always pushing out the latest version. At that time, we were using the Hockey app solution to push out the OS for the mousetraps out into the warehouse, and ensuring that all the mousetraps were abiding by the latest OS that was created for them, as well from a security perspective. At that time, we were using certificates as tokens to ensure that only IoT Hub had access to the mousetraps themselves, and the information that was being captured at that time was actually being captured into Azure SQL. The whole aspect of the information being locked out is an important one, especially if you deploy these mousetraps in, let's say, an organization like a restaurant. You don't want the general public to know how many mousetraps you have deployed, and you don't want somebody getting into your network and understanding, oh, this restaurant has 100 mousetraps. If I share this with information, and remember, data is the new currency. If I share this information with the world, and it becomes a challenge in respect to everybody knows how many mousetraps are at that restaurant, I'm not going to go eat at that restaurant. So it's that whole aspect of security piece in terms of who has access to what. And at this time, when this solution was being deployed, there was no just-in-time configuration. Now, the whole ability to govern right down to the mousetrap itself and say only certain individuals have the ability to go in and manipulate and access the OS on this device or the data that this device is capturing is an important one. And it's securing the endpoint from a IT perspective is an important one, because we secure devices all day long, mobile devices, laptops, you name it. And why should an IoT device be any different? It connects to your network, even if you have it as a segmented network outside of your organization or on its own segment. You still have to govern and you still have to manage that infrastructure. So having that ability to do so, it's only been getting better and better since the solution has been deployed. Now, as I mentioned, a lot of the data that was being captured from the endpoints, which was the mousetrap, was being fed into machine learning. And so an algorithm would then go forth and just digest in terms of mousetraps being set up by the mice, where is the best places to put the mousetraps inside of that warehouse. So the 100 mousetraps that were deployed, we were actually shuffling around in terms of the warehouse itself by triangulation, utilizing the Wi-Fi router to understand where was the best places to put these mousetraps out to catch the most mice. Now, if you saw on my previous slide, there was a URL. I'll also share my GitHub URL. And the reason why I do that is because the solutions and the technologies that we talk about, we then share with the masses, which is you. And you take advantage of the code that we've already created and you evolve that code. So using that same architecture from the mousetraps, we have a local newspaper publishing company that has taken advantage of this architecture. And instead of the mousetrap and a mousetrap being set up to do the capture of information, they've actually deployed weights or weight scales inside of the newspaper boxes. You've probably seen these on the sidewalk out by the streets that sell the newspapers. In this scenario here, there's a weight scale that's inside of this box. And when the weight scale gets to a certain threshold in terms of the amount of weight inside of that inside of the newspaper box, it sends the information to say, this is how long until all the newspapers in this box were sold out. And so it gives the publishing company an understanding of, hey, this is the best times to go out and put new newspapers or put more newspapers into the boxes, or maybe even move the location of the box altogether because the fact it's not selling enough newspapers. Again, security comes into play in respect to this, so that nobody is tampering with the information and what's being captured from the newspaper boxes, as well as where does the data reside in terms of the geographical region for all these newspaper boxes. Same holds true for police services. So one faction of the police services took advantage of this architecture as well, and their trigger in this scenario was the sirens on top of the police cars or the police cruisers. And so when the siren actually went off, that was the trigger to put a dot into geographical region as to where the siren actually was turned on. And then using that same architecture, having that understanding in regards to where is the places that require the most police presence. And so being mindful in regards to, if we're getting a lot of calls in this area, we should send more cruisers to this area. Again, based on the mousetrap architecture, to understanding in terms of patterns of where the police would be best suited to support the public in specific areas. So we talked about devices that are being connected in regards to how the device at the endpoint can be secured and can be managed from an OS perspective in terms of operating the proper OS. What happens now when you take this and you extend this to the edge? So now what we're doing is we're looking at IoT devices that actually have compute power at the edge that can actually digest the information. the scenario here is we're capturing a lot of data. It's it's teraflops of data that's coming in. It's insane the amount of data that's coming from all these devices that are connected, and you can't store everything. You can't house everything in terms of data, nor would you want to. I've been on a couple of projects where it takes a group of people days, if not weeks, to digest information. And if we have the ability in terms of compute cycle at the endpoint to digest the information as it comes in, why wouldn't we take advantage of that? Why wouldn't we capitalize on the compute power that's there on the edge? And that poses its own problems, though, because in that scenario, how are you governing over the OS? How are you governing over the data that's being captured at that endpoint and being digested? It could be very easy for somebody to go in and inject code into these devices and circumvent the security and then do whatever they're planning to do with the data. One piece or technology or service that you should be looking at, especially if you're deploying an edge solution, is Azure Sphere. And Azure Sphere is that ability to secure devices on the edge with the certificate or token technology that is chipset based. So in essence, you're pushing the equivalent of an Azure AD certificate to a device to ensure that this device has a secure connection to IoT Hub to transpose or push out that data. In this scenario, you're guaranteeing the security of that device, and if the device itself is being tampered with, it then becomes self-aware and provides itself a remediation in terms of how do I then fix the problem. If somebody's hacked the OS or somebody's trying to inject code into this OS, how do I then address it? And in the Azure Sphere scenario, what happens is it'll actually take itself offline and disallow any further data to come from the device to be pushed out to the hub. It then pings back to the hub and say, what is the proper software that I should be running on this device, or proper OS that I should be running on this device, and then push out the data to, having the hub push out the data or the OS or the software back out to the IoT device to run the proper code. So in that scenario, in terms of a deployment, I'm going to show you a high-scale deployment implementation that we looked at the scenario in terms of security piece. And this here is the Henry Lawson. This is the largest ship that they have on the Canadian Coast Guard fleet. And for this ship to leave the dock, it's millions of dollars. It's astronomical in terms of cost. But saving lives, there's no price tag on saving lives. It's important. So in terms of these ships that are going out there, there was a request from the Canadian Coast Guard in terms of how can they become more proactive in respect to helping people when they're in distress. How can they become, in an understanding in terms of what services are required to rescue these people? And so we had put together a proof of concept with them in an organization called Indro to make devices, in this example, drones, more self-aware, more intelligent in respect to what they're looking at. Prior to, there was a pilot that would fly the drone out to the emergency area. It could be up to 3 hours out at sea, and take film of the entire area. And then in respect to that, understand, the video that's being captured then has to be flown back to the central office via the drone. And then once the drone comes back to the central office, the data is extracted and somebody has to run through all that data. Now, we went through a ton of scenarios in terms of how we can better adopt technology to assist in respect to understanding the footage that was occurring. Initially, what we thought was if the drone went out, filmed the 3 hours of footage and flew back, the operator would have to watch through 3 hours of footage in respect to what the drone was capturing, and that took a long time. So if we were to apply machine learning at that aspect, but still 3 hours of film would still have to be gone through, and time is of the essence when you're trying to save people that are in distress. So that wasn't an option. The second option was, the initial option that they were looking at was, with the drone being out at sea, is there a cost-effective way to provide connectivity to these drones? Because the fact there is no Wi-Fi internet connectivity when you're out at sea, so the only options would be satellite, which was very costly at the time in respect to the drone then piping a feed back. And for rescue services, there's a requirement for a minimum 720p in terms of data stream or in terms of video capture, and that alone becomes a challenge in respect to the data that's being transposed back and forth and the cost in respect to that. So we toyed with the idea in terms of how about making the drone intelligent? How about providing an understanding to the drone to understand what the drone is actually looking at in respect to the ship being in distress? Now, What we did at that point is we looked for a constant. What is something that we can identify as a trigger, similar to the mousetrap going off, to invoke the drone to request assistance in a scenario? And the one thing that we all came to a conclusion of in this proof of concept was the identification of life jackets in the water. So the piece here was detecting a life jacket off of the ship on the water, and then as the beginning of the trigger, and then following up that trigger with regards to an IR scan of the body mass inside of that life jacket as the verifier that there's actually an individual inside of the life jacket. And that was important, right? Because if a life jacket falls off the ship, it's great that you can detect it, but you want to ensure that there's actually an individual or a body that's inside of that life jacket in terms of somebody that needs to be rescued. So in terms of this implementation, pushing off computer vision, using containerization in this scenario, the ability to run the operands to say when this drone is going out and identifying the life jacket in the water and identifying that there is a heat mass amidst that life jacket itself, having that as the trigger to say, okay, there's a ship in distress, this amount of individuals are actually in the water, and then doing a capture of environmentals around the distress area itself, so around the individuals that are in the water. And that's to do a calculation, a rudimentary calculation in terms of how many hours or minutes before hypothermia sets in. And so this drone, again, remember, there's no connectivity allowed for it, would then have to fly back into connectivity to report back to say, hey, I just detected in this scenario that there is a ship in distress. There were 4 people in the water, and if you don't get support out there within an hour and a half, they will suffer hypothermia. You need to get people out there right away. What a huge benefit in regards to reporting of this implementation, reporting of the life jackets being out in the water with individuals in them to say that there is distress, that they have to go out and rescue these individuals. Huge importance, and doing so in such a way that makes it more automated in regards to response. The drone would immediately, after doing the detection, capture that information and immediately fly back to the CO into coverage to get connectivity for data to transpose that information. Hugely important to allow for organizations to have information at their fingertips as it's needed. There's a quick question on the chat window. Bring up, do you know of any cases of less traditional computer vision, such as infrared or thermal vision? Actually, so the drone solution is just the one. I'm actually going to share another one with you. But before I do that, I'm going to actually do the computer vision demo, similar to how we did the detection of the life jackets. But Matthias, I will share another example with you in regards to implementation of IR scanning that's actually being used in production today. First, let's quickly go through this, and if you haven't seen this before, this is the computer vision workbench that we have available. This allows you to go forward and add images to teach computer vision what objects look like. So in the scenario of life jackets, we had to show, we standardize on the orange life jacket. Different shades of orange were used for training in terms of different bodies of water, dark bodies, light bodies of water, in respect to cloud coverage or a sunny day or a rainy day. All that information was captured. It was 5,000 hours of teaching to computer vision in terms of the different visuals that life jackets would put off. But in this scenario here, what we're actually going to do is we're going to do some hardware distinguishing. Because in fact, I'm going to show you another cool project that I have in my GitHub repo that is based on the drone life jacket scenario that you can actually repeat in your home offices. So in this scenario here, we're going to do is distinguishing between different tool sets. In this set here, you can see that these are hammers. And so we've uploaded this into computer vision. If you want to go to the computer vision websites, computervision.ai, this allows you access to this workbench. And in this scenario here, these are a bunch of hammers that I'm teaching computer vision, but these are actual hammers. And then we include wrenches. So we're going to try to teach computer vision to distinguish the difference between a hammer and a wrench. And in this scenario here, in terms of wrenches, we have a bunch of adjustable wrenches. We also have the actual scale set wrenches that are being added. And we add a tag. So as you can see, we've added the hammer and wrench tag to the images, teaching computer vision to learn what these tools actually look like. Once we've completed this, we're going to train the model so that it can actually, based on feedback, based on the imagery that's there and the tagging that's been, to identify what object is what. And then we get a recall in regards to the precision that computer vision actually has in terms of understanding the objects that it's looking at. In this scenario here, in terms of the recall, we can see at 96% accuracy, the computer vision service can detect the difference between a wrench and a hammer. At this point, and this is what we did for the drone solution as well, we then export the solution to be made available in terms of its platform, in terms of on an edge computing scenario, what is the best way for the IoT device that's going to be having this type of intelligence to digest the information it's capturing through that endpoint. So as mentioned in the terms of the drone scenario, we actually use a Docker file to run on top of the IoT device to have the ability to understand the information that it's looking at. But in this scenario here, what I'm going to do is I'm actually going to export it as an ONNX file. And the reason why I'm going to export it as an ONNX file, it is the smallest footprint that you can output in terms of intelligence and understanding the logic behind identification of objects that you can implement. Obviously, security would be that much more stringent on a Docker implementation than more so than an ONNX implementation. But remember, security also abides by the device that you're deploying the solution on. And so if the device itself has the security attributes, you can actually lock down the device pretty securely in terms of the enablement of who has access to what data. So in this scenario, as mentioned, we're going to export it as an ONNX file, so ONNX 1.2. And what we're going to actually do is we're going to spin up Unity. And you're probably catching on in terms of what we're going to do in this scenario here. I'm actually going to take the ONNX file, I'm going to convert it into a model file and have that as my filter on my device, in essence, a HoloLens, to have an understanding of the items that are surrounding the HoloLens itself. So imagine, if you would, putting the HoloLens on and via the camera on the HoloLens without connectivity, disconnecting the connectivity, no Wi-Fi connectivity to the device, I actually have the ability to go around and detect objects that the HoloLens is actually looking at. I'm going to show you an example in a second. As mentioned, I'm sharing my GitHub repo where this project actually resides, aka.ms/wirelesslight, if you want to gain access to this solution. So in the scenario here, this is me walking around in the backyard. As you can see, the HoloLens can detect a basketball with 69% accuracy, actually 82, and it fluctuates in terms of, you're looking at objects at different lights. So soccer ball or a football for my European friends. Walk into the house, I can actually see a piano. And this is, again, the HoloLens distinguishing between objects using the same architecture that we had for the drones, a little bit more advanced because this project's a lot more recent, and having an understanding of the devices that the HoloLens is looking at without connectivity. Now, a lot of people come to me and say, well, that's great, Anthony, but, HoloLens out of my price range or not available for my organization in the country that I live in. I wanted to introduce this to you. This is the Azure Connect SDK. This is something where available worldwide. It is a camera that has IR capabilities and the ability to understand depth and the ability to understand, imagery in respect to this connecting to a central computing unit like a Raspberry Pi or an NVIDIA Jetson, and having the ability to distinguish between objects or distinguish between heat masses. This is a solution that's a lot more available around the world. HoloLens is available, of course, HoloLens 2, but from a perspective of if you're doing a POC, HoloLens might be expensive if your organization can't support it. So going down with something like this to do a proof of concept before purchasing a HoloLens might be optimal for a lot of organizations to test out their theories. So this type of device and implementation is actually being used in Australia, again, based on the architecture made available by the drone scenario for the Canadian Coast Guard, using the technology to understand soil dampness inside of farmers' fields. So in this scenario here, they're using the drones to fly over the farmers' fields and to measure the amount of water inside of the fields that is available, and understanding that if the field does not have the optimal amount of water, that the irrigation would have to be turned on in terms of watering the fields themselves. Again, connected to the drone device, the drone operating the irrigation system and providing that ability to water the crops as needed based on the drone's detection of the soil dampness and the amount of water that's in the soil itself. So, and this is why I love sharing the GitHub repos that we made available in terms of projects, because others can build on top of the projects that we've created to build out these fantastic solutions and have a leg up in terms of understanding the research that was put forward through the proof of concept and deploying it in their own means to implement these technologies in an appropriate way and in a secure way. And it's something that a lot of organizations can go and adapt. So what's next, right? And so I showed you the example of HoloLens. You know, when the HoloLens came out, this was the idea that HoloLens was going to be this new entertainment device that can go forward and understand, you know, imagery or to project imagery on flat surfaces to do 3D or mixed reality augmentation or interaction with objects. And yes, and it's still being used for that. There was a lot of organizations that have deployed these solutions in respect to, you know, how to repair a specific engine or to walk through scenarios that may be dangerous and to do so in such a way where it's through mixed reality to have an understanding what they're looking at. But what's great is that in terms of this implementation and specifically around IoT, having that sensor from the outside feed the information to devices like a HoloLens, like your cell phone or smartphone, like any mobile device that has connectivity, having the ability to augment the world. In this scenario here, we work with a partner, T4G, on behalf of an engineering organization. They have the ability to understand pipeworks inside of a building. Obviously, the schematics were fed into the solution in terms of what actually resides behind the walls, but having the ability to use the HoloLens, having the HoloLens understand what room they're actually walking into, and having an understanding of how the piping inside of that room is laid out, and having the ability to, you know, affect. So I can detect that there is going to be a water pressure issue in the pipes in room B. I can actually go down to room B, look at the wall, and understand the pipe layout inside of that wall, point specifically to the valve that I need to adjust, and then using actuators in the valve, making the hand gesture in front of the HoloLens to actually open and close the valve as required, specifically to address the water pressure issue. This scenario here, again, proof of concept, and again in my GitHub repo, provides the ability to extend the HoloLens reach or understanding of the area that it actually abides into in terms of geomapping and having an understanding in terms of this is the room that I'm in, or this is the pipes that reside behind the wall. It negates the need for organizations to break drywall should there a problem arise, because the fact that you have the ability to control everything from your hands inside of the room itself without actually going in and affecting the drywall. And having the ability to affect the pipes in a real world sense, not in a virtual sense, using the gestures being available through the HoloLens itself. So one last example, again, based on the solution that was put forth on both the Mousetrap and on the drone scenario for the Canadian Coast Guard, work with an organization called HomeEXCEPT that actually monitors senior citizens in their own home. And this was an interesting one. It's an interesting project because of the fact that the data sensitivity on this one is very high. This is an ethics lesson that our team experienced when doing this project. Having cameras in people's homes is a troublesome issue. So what we actually did was, instead of cameras, we took the technology that we learned from the drone scenario and actually used IR scans to track heat masses inside of the home, and having an understanding in terms of feeding to machine learning where the body mass would travel throughout the home through certain times of the day, having understanding of what time an individual wakes up, what time an individual goes to the bed, what time they make lunch, what time do they feed their pet. All this information being captured to have an understanding in regards to, okay, in regards to this individual, what time they wake up, what time they go to bed, and so on and so forth, the way that they go out and live through their day. And the ability here to have an understanding of those patterns allows, you know, the solution to be proactive in terms of distress. When this individual has an issue, is unable to get out of bed, having the ability to share that information to loved ones when that individual is in distress. I know, you know, a lot of people do not want to wear medical devices to press a button when they're in distress. And so the ability to automate the solution and to be proactive in terms of the detection was crucial in terms of this scenario that's currently in testing in terms of facilities that have individuals that would require this service. So the future of computing, and I've got 1 minute left, really want to quickly run this off, is all about you. It's everybody who's attending Build, everybody who's absorbing all the information, all the ideas, you know, they're inside of you. There's something that you're either doing on behalf of an organization or in regards to yourself. Have the ability to explore, have the ability to be creative, but also, you know, be mindful, have that open conversation with IT. We can help. We can help in terms of architecture. We can help in terms of security and operations. We can help in terms of relaying your message to the masses amidst the organization that you support. It's the whole ability to work together for the common good to enable everybody to move forward together in terms of adoption of technology. A lot of the talk today that I've shared with you, available documentation is on docs.microsoft.com, as well as, and this is the way I learn in terms of adoption of technology, Microsoft Learn, so microsoft.com/learn. A lot of hands-on labs. In some scenarios, there is sandbox technology that allow you to actually play with said technology inside of the cloud at no cost to you. A great learning resource. A lot of the IoT examples that I've shown here, I've actually built out into modules. The edge computing module just actually went live yesterday for you to go out and test out theories around the technology of that type of implementation. Also, certification is also important in regards to upskilling. In some scenarios, especially for ISO standards, certification of individuals is also required. So do take into consideration this as well. And we are at time. So if you have any questions, feel free to reach out to me. You can find me on Twitter at WirelessLife. I contribute content regularly to itopstalk.com, and our entire team is on Twitter. So if you want to reach out to us, it's #AZOps. And as promised, my GitHub repo for a lot of the projects that you've seen here, aka.ms/wirelesslife. You have been a fantastic audience, and enjoy the rest of your time here at Build.